Dear students, good afternoon everyone. I hope that you are all well prepared for tomorrow's examination. Have you all prepared well? Okay, you will be having the examination in the live session itself. As usual, you are requested to join at sharp 3. Please don't be late. Okay, if you are late, you will be getting only less time to complete the test. Once the time limit is over, the question paper will not be submitted. So please join the class at sharp 3 from tomorrow. And right now you are going to have revision of physics.
Right. So here, introduction to acids and bases. So here, what is the first thing that comes into your mind when you see this? Here, we must be like this here this is sweet and a bitter gut, bitter, and this lemon, sour taste, right? So that the first thing comes to your mind while looking at these things is the taste, right? So we generally associate these things with their taste, right? So here, yes. So when a scientist in Greece, they were trying to classify different substances. They tried to associate the things with their taste, like sweet, sour, bitter, salty, right? So they found that the sour tasting things, okay, so the sour tasting things, all the sour tasting things, they showed the similar properties. Okay, they found that all the sour tasting things showed similar properties as well. They named chemical sour tasting things acids. Okay, so here all the sour tasting things show similar chemical properties as well. They named as sour tasting things, that is acids. So this acid come from Latin word acidus. Okay, this acid come from Latin word acidus, which means sour. So here, all the sour tasting things they found out, they showed the same taste and same type, right? So they were showing similar chemical properties. So here some of the naturally occurring compounds, right? So we are seeing that an acid is a chemical substance that has a sour taste. So many food items such as lemons, curd, vinegar and orange taste sour because of the presence of acid in them. So acidic substances are the substances that contain acid in them. So here some of the naturally occurring compounds which contains acid. You can observe the examples here. Lemon juice, orange juice, vinegar, curd, tamarind, amla, and mango, grapes, right? So all these are sour tasting fruits or sour tasting things. So here we can consider all these are acids, right? Here also same examples. So look at this table here. So here name of the acid given and here in which it is found, you can observe clearly here. So here name of the acid, acetic acid. So this acetic acid found in vinegar. Okay, right. And next one, name of acid, formic acid. This formic acid found in ants' sting. Okay, so when ants sting on skin, so the ants will release formic acid. Okay, so in Latin word, ants are known as formica. Okay, so from that we are naming this acid as a formic acid. So that is found in ants sting. And next one, citric acid. So this citric acid found in citrus fruits such as oranges, lemons, etc. Right? And next one. Observe the fourth one here, lactic acid. So here this lactic acid found in curd. Okay, next one, oxalic acid. So this oxalic acid found in spinach. Okay, next one, ascorbic acid. That is vitamin C. So this ascorbic acid found in amla and citrus fruits. Yes, next one, tartaric acid. Okay, tartaric acid. So this tartaric acid found in tamarind, grapes, and the mangoes, etc. So here all the mentioned acids, all the acids mentioned above occur in nature. Right? So here vinegar, sour milk, and these citrus fruits, lemon, orange, right? Kiwi fruits, pineapples, cherries. So here tomatoes, grapes, apples, tamarind, all these are comes under acids. Okay, next one, base. So here bases are bitter and slippery. That means here the second type of substances that were bitter, and they also show properties like they were slippery in nature. Okay, bases are bitter to taste and they were soapy to touch, that means slippery in nature. So bases are found in different substances such as bleach, ammonia, washing powder, and soap. Right? So we are saying that bases were substances that were bitter tasting and they showed some additional properties like slippery in nature. Right? So here some of the examples of base given: detergent, baking soda, drain cleaner, antacid base, ammonia soaps, that means hand dishwash bar, like this lime water. All these are comes under the bases. So here lime water is not a lemon water. Okay, so look at this word here. Lime water means that is formula is CaOH taken 2. Calcium hydroxide is also known as lime water. So when we mix calcium oxide with water, it will form calcium hydroxide. Okay, that is a lime water. So here it is base. Lemon water is acid. Okay, lime water is different and lemon water is different. So here we know bases were substances that were bitter tasting and showed some additional properties like slippery in nature. So we know substances like soap, oil, mustard oil, etc. All these are slippery in nature. Right? You can see the figures also here. Right. So here, observe the chemical properties of acid sine bases. Okay. So for this activity, yes, we need to collect the following samples, right? Those are hydrochloric acid, sulfuric acid, nitric acid, acetic acid, sodium hydroxide, calcium hydroxide, magnesium hydroxide, ammonium hydroxide, potassium hydroxide. Okay, so all the formulas also given here. So you have to learn each and every formula, right? So here we have to collect all these substances. So now we have to prepare dilute solutions of the respective substances. Okay, so we collect all the samples given here, right? So we have to prepare the dilute solutions. Okay, so here we are taking only dilute solutions, not concentrated solutions. Okay, so when we add water to the concentrated acid or base, it becomes dilute. Okay, the concentration of the acid or base decreases there. Okay, so when we add acid or base to water, then the concentration of the acid or base decreases, right? So it becomes diluted there. Right. So here we have to prepare all dilute solutions given here. So we have to take 4 watch glasses. Okay, here we have to take 4 watch glasses. Now, put 1 drop of the first solution in each one of them and test the solutions as follows. So here we have to take 4 watch glasses. Right? So here the first solutions which we are taking here, HCl. Assume that we are taking HCl solution. Right? So here we have to put 1 drop of HCl in each watch glass. Okay, so here put 1 drop of the first solution in each of them and test the solution as follows. Now we are going to test this HCl solution following here. So look at here. So here we are taken in each watch glass 1 or 2 drops of HCl, right? So now dip the blue litmus paper in the first watch glass. So here in the first watch glass we are taking blue color litmus paper. Right, we have to dip the blue color litmus paper in the first watch glass. And next, dip the red litmus paper in the second watch glass. Okay, next, add a drop of methyl orange to the third watch glass. Okay, so to the third watch glass, we have added 1 drop of methyl orange. And next, add a drop of phenolphthalein to the fourth watch glass. Okay, to the fourth watch glass, we have added a drop of phenolphthalein indicator. Okay, right. So here we have to observe the changes in all the watch glasses here. So here, first of all, we have taken in all the watch glasses HCl solution. So like that, we have to take all the samples here after 1 by 1. So after HCl, we have to take H2SO4. After that, we have to take HNO3. After that, we have to take sodium hydroxide. Like that, we have to do this experiment with all the samples. So we have to note down the observations. So look at here. We have taken 4 watch glasses, right? So we have tested all the samples with the red litmus paper, blue litmus paper, phenolphthalein indicator, and methyl orange indicator, right? So here, observe the changes here. So first of all, we have taken sample solution HCl, right? So here, in all watch glasses, we have taken HCl solution. So when we dip red color litmus paper into the HCl solution, the red color litmus paper remains as red color only. Here, the red color litmus paper unchanged. Okay, the color remains as red here. Next, blue color litmus paper. So here, the blue color litmus paper in HCl solution turns to red. Okay, so here the blue color litmus paper changed into red color. And next, phenolphthalein indicator. So when we add a drop of phenolphthalein indicator to HCl solution, the color of the solution remains same. That means it is colorless. Okay, we observe water-like substance only. Right? Next, by adding of methyl orange to the HCl solution, the color of the sample changed into pink or a pinkish red color. Okay, sometimes it will change into completely pink or pinkish red color. Yes, so here these observations gives us an information that HCl is an acid. We know in acid solutions, blue color litmus paper turns to red, right? And in base solutions, red color litmus paper turns to blue. And we know phenolphthalein indicator in acid solutions, it is colorless. And in base solutions, it changes the sample solution into red or pink. And methyl orange. So when we add methyl orange to acid solutions, the color of the solution changed into pink or pinkish red color. And when we add methyl orange solution to bases, the color of the solution changed into yellow. Okay, so here by these observations, we can say that here HCl is an acid. Here red color litmus paper remains as red color only because here the solution is acid, right? So that's why here red color litmus paper, it remains as red, right? So here blue color litmus paper changed into red. So this indicates that the solution is acid. And phenolphthalein indicator is colorless. It changed the solution into colorless, right? So here this indicates that the solution is acid. And methyl orange indicates that the solution is acid here by observing the pinkish red color, right? So next one, H2SO4. So this time we have to take in all the 4 watch glasses H2SO4 solution. Again, we have to test the H2SO4 solution with red litmus paper, blue litmus paper, phenolphthalein indicator, and methyl orange indicator. So here also H2SO4 is one of the acid. So blue color litmus paper unchanged, red color litmus paper unchanged, and blue color litmus paper turns to red. Phenolphthalein indicator, by adding of phenolphthalein indicator, the solution remains colorless, and by adding of methyl orange solution to the sample, the solution sample changed into pinkish red color, right? So all these observations gives us H2SO4 is an acid. Now, next one, HNO3, right? So here now we have to take in all 4 watch glasses HNO3 solution. So now here by using of red litmus paper, the red litmus paper is remains as unchanged. So it is remains as red color only. And blue color litmus paper changed into red. And by adding of phenolphthalein solution, the solution sample is remains colorless. And by adding of methyl orange, the solution sample changed into pinkish red color. So by all this information, we can say that HNO3 is an acid. And next one, you can observe CH3COOH. Here, this is also an acid. Okay. And next, observe the next one, sodium hydroxide, right? NaOH. Now, in all the 4 watch glasses, we have to take a sodium hydroxide solution. Now we have to test this sodium hydroxide solution by using of all these indicators, right? Red litmus paper, blue litmus paper, phenolphthalein indicator, and methyl orange indicator, right? So here, when we dip red litmus paper in the sodium hydroxide solution, the red litmus paper changed into blue. Okay, so here the red litmus paper changed into blue. And blue litmus paper, it is remains as blue. The color of the blue litmus paper unchanged. And by adding of 1 drop or 2 drops of phenolphthalein indicator solution to the solution sample of sodium hydroxide, the color of the sample solution changed into red or pink. And by adding of methyl orange, the solution is remains as yellow. So here, by this information, we can say that sodium hydroxide is one of the base. Okay, so here we have KOH and MgOH taken 2, NH4OH and CaOH taken 2. So all these are comes under bases. Okay, so here HCl, HCSO4, HNO3, CH3COOH, all these samples are right acids. And here this remaining sodium hydroxide, potassium hydroxide, magnesium hydroxide, ammonium hydroxide, calcium hydroxide, all these are bases, right? See the next one here. Activity 2. Now here we have to put some finely chopped onions in a plastic bag. Okay, so we have to put some finely chopped onions in a plastic bag along with some clean cloth. Okay, in that plastic bag we have to keep the one clean cloth also. Okay, along with that chopped onions. So now tie up the bag tightly and keep it overnight in the fridge. Okay, so here the cloth strips can now be used to test for acid or base, right? So here along with the chopped onions, we are kept some clean cloth. So here now we have to check the odor of the cloth strips. Here keep 2 strips on a clean surface and put a few drops of dilute HCl on one strip and few drops of dilute sodium hydroxide on the other. Right? So we have to take out the clean cloth from the plastic bag. Right? Now we are going to test this cloth strip by observing odor, whether it is acid or base. Right? So here taking here HCl solution and a sodium hydroxide solution. So here we are taking both dilute HCl and dilute sodium hydroxide. So here keep 2 strips on a clean surface and put few drops of dilute HCl, right, on one strip, and few drops of dilute sodium hydroxide on the other. Right? Now, rinse both the strips separately with distilled water. And again, check their odor and note down the observations. So here, now we have to take some clove oil and vanilla essence. Right? So here, take some dilute HCl in one test tube and dilute sodium hydroxide in another test tube. So add a drop of dilute vanilla essence to both test tubes and stir well with a glass straw. Right? So in one of the test tube, we are taking HCl solution, and in another test tube, we are taking sodium hydroxide solution. Right? So here we are adding a drop of dilute vanilla essence to both test tubes. Okay, and we have to stir well with a glass rod. Now we have to check, we have to record our observations. Now, test the change of odor with clove oil using dilute HCl and dilute sodium hydroxide. Right? So here. Now, suggest which of these, onion, vanilla essence and clove oil, can be used as olfactory indicators on the basis of your observations. Right. So here we can use this onion, vanilla essence and clove oil as olfactory indicators. Right? So here we have tested this onions, vanilla essence and clove oil with dilute HCl and dilute sodium hydroxide solutions, right? So here in dilute HCl solution, the onion or vanilla essence and clove oil change their smell, right? Means we will not observe any smell there. But in the sodium hydroxide solution, we'll observe the smell. Okay. So here that indicates that here these onions, vanilla essence and clove oil are used as olfactory indicators. Right? Yes. Now, here observe the reaction of acids and bases with metals. Right? Look at here. To observe the reaction of acids with metals. First of all, we are observing the reaction of acids with metal. So here we have to arrange the experiment as shown here. So we are taking some materials here, test tube, delivery tube. Okay, so this is a test tube here, right, given here. This is a test tube and this is a delivery tube, right, and one glass through, okay, and soap water and dilute HCl and zinc granules. So these are the materials required here. Now, here we have to arrange the experiment as shown here. First of all, we need to take about 10 ml of dilute HCl in a test tube. Okay, so in the test tube, we have to take dilute HCl 10 ml. To this HCl solution, we have to add a few zinc granules. Right? Now, what do we observe on the surface of zinc granules? So after some time, from the zinc granules, we'll observe releasing of some gas like bubbles. So now we have to pass the gas being evolved through the soap water. Okay. Now, so why are bubbles formed in the soap solution? Now here, bring a burning candle near the gas-filled bubbles. So what do you observe here? So you'll notice that the gas evolved burns with a pop sound indicating hydrogen. Okay, so here the burning candle or burning matchstick is put off with pop sound. So that pop sound indicates from the solution hydrogen gas is released. Right? So here, what is a chemical reaction in between HCl and zinc granules? So here, we are taken HCl and zinc granules in a test tube. So here, these zinc granules are reacted with HCl solution. Right? So after some time, we observe releasing of gas through this test tube. So that releasing of gas passes through the delivery tube into the soap water solution. So here that gas released from the soap water like bubbles. Right? So we don't know the gas, which gas is released from the test tube. We have passed that gas through the delivery tube into the soap water solution. So from the soap water, we are observing the evolution of bubbles, right? So when we bring a burning matchstick near to the bubble, so here this matchstick makes one pop sound. So that indicates that gas is evolved, that is hydrogen gas. Right? So when we repeat this experiment, instead of HCl, H2SO4 and HNO3, we'll observe the same results. Right? So we'll observe releasing of hydrogen gas from the solution. So here the chemical equation or chemical reaction here, HCl is the acid, right? So zinc granules are, that means zinc is metal here, right? So here acid and metal are reacted. So when an acid reacts with metal, will form salt and releases hydrogen gas from the solution. So here the acid, HCl acid, right? Metal, zinc metal, salt formed by these two reactants, zinc chloride, that is ZnCl2, and hydrogen gas is released from the solution. Right? So here 2 molecules of HCl reacts with 1 molecule of zinc, right? Forms 1 molecule of zinc chloride and releases hydrogen gas. Right? So we can conclude that generally hydrogen gas is evolved when acid reacts with metal. Now, we observe that when acid reacts with metal, hydrogen gas is evolved. Then what about bases? So here we have to take, instead of HCl solution, we have to take sodium hydroxide, right? Now, we have to repeat the experiment. Instead of HCl solution, now we are taking sodium hydroxide. Now, place a few zinc granules of zinc metal in one of the test tube and add 10 ml of sodium hydroxide solution. Now warm the contents of the test tube. Okay, so now in this also we will notice that evolved gas is hydrogen and salt formed is sodium zincate. So here also, so here instead of HCl we are taking sodium hydroxide, right? We are taking zinc granules in the test tube. So we are heated this contents, right? So once these contents are heated, from this test tube we observe releasing of gas. So the released gas is passed through Delver tube into soap water solution. So here also we'll observe evolution of bubbles from the soap water solution. So when we bring burning matchstick near to the bubble, here also this burns and making a pop sound. So we'll notice that gas evolved is hydrogen. Okay, so the reaction between these two molecules here, sodium hydroxide we are taken and zinc metal we are taken. So sodium hydroxide is a base and zinc is a metal, right? So it formed salt and releases hydrogen gas. So from this we can conclude that generally hydrogen gas is evolved when bases reacts with metal. So here we are taken, this is a metal, okay? This is not an acid. Sodium hydroxide is a base. So here we are taken base with a zinc metal. Here also we observe releasing of hydrogen gas from the solution, right? So, but this is not possible with all the metals. Okay, so when we are using bases, this is not possible with all the metals, right? Now, so next one we have a reaction of acids with carbonates and metal hydrogen carbonates. So here in the previous activity, we observed that when an acid reacts with a metal, it will form salt and releases hydrogen gas, right? So we repeat the experiment with base also. So here, there we observe again releasing of hydrogen gas. We conclude that when an acid reacts with metal, hydrogen gas is released, and base reacts with metal, hydrogen gas is released. So one important note there. So it is not possible with all metals. Okay. So now, here the reaction of acids with carbonates and metal hydrogen carbonates. Look at here. For this, we need to take 2 test tubes. Okay, so we need to take 2 test tubes. So label them as A and B. So take about 0.5 grams of sodium carbonate. The formula of sodium carbonate Na2CO3. Okay, so we are taking 0.5 grams of sodium carbonate in a test tube A. Right now, and about 0.5 grams of sodium carbonate in test tube B. So here it is showing only test tube A. So we have to take 2 test tubes. So in the both test tubes we have to take. So in one of the test tube we have to take 0.5 grams of sodium carbonate, that is Na2CO3. In another test tube we have to take sodium hydrogen carbonate, that is NaHCO3. Okay, now add about 2 ml of dilute HCl to both the test tubes. Okay. So here you can observe only one test tube. So in this test tube, we have sodium carbonate, Na2CO3. To this test tube, we have added 2 ml of dilute HCl. Okay. In another test tube, we have to take sodium bicarbonate, that is NaHCO3. So to this test tube also, we have to add about 2 ml of dilute HCl. Now, what do you observe here? So here, when this dilute HCl is added to sodium carbonate, right? Carbon dioxide gas, right? So released from this solution. So here, observe that pass the gas produced in each case through lime water. So here we are taken in another test tube lime water. You can observe the test tube. So in this test tube we have lime water, that is calcium hydroxide solution. Now, so from this calcium hydroxide solution, it releases gas, that is a CO2 gas, right? So now we are passing that gas through the delivery tube into the solution here. Now, so the reaction in this activities. So we have taken sodium carbonate. To this sodium carbonate, we are added 2 ml of HCl, dilute HCl. So in that test tube, we observe sodium chloride, water, as here. And in the test tube 2, we are taken sodium bicarbonate or sodium hydrogen carbonate and HCl solution, dilute HCl, right? So in that test tube also we'll observe releasing of the products are sodium chloride, water and carbon dioxide, right? So here carbon dioxide is released from test tube A and test tube B. So these are the chemical reactions in test tube A and test tube B. So now we pass the gas evolved through lime water, right? So here lime water is a calcium hydroxide. So we pass the CO2, right? So it will form white precipitate, that is CaCO3, right? So here in that test tube, we will observe CaCO3 and will observe water. So this CaCO3 white precipitate is settled down at the bottom of the test tube. So now on passing excess carbon dioxide, we'll observe that this CaCO3, that means this white precipitate will soluble in water. When we pass some amount of gas through the test tube, we'll observe white precipitate in the test tube. But when we pass excess of gas into the solution, we'll observe that precipitate soluble, right? To this CaCO3 precipitate, we are passed excess of carbon dioxide. So that there we'll observe this precipitate will be dissolved, right? That is soluble. So CaHCO3 taken 2, that is aqueous solution. So now, so from these activities, we can conclude that the reaction of metal carbonates and hydrogen carbonates with acids give a corresponding salt, right? And carbon dioxide, water. So here we can write a generalized form of these chemical reactions here. So metal carbonate reacts with acid, form salt, carbon dioxide, water. And metal hydrogen carbonate also reacts with water, forms salt, carbon dioxide, and water. Okay, so when metal reacts with acid, releases hydrogen gas, and when metal carbonate reacts with acid, releases carbon dioxide gas, right? So we'll discuss the
The aim of the topic is understanding about polynomials and solving exercise 1.3.1, 3.2, 3.3 and 3.4 problems. Okay. So the agenda is knowing about polynomials, okay, types of polynomials and linear polynomial, quadratic polynomial, sum of the zeros and product of the zeros, okay, cubic polynomials, right? So first of all, what is polynomial? What is polynomial? See, a polynomial is nothing but an algebraic expression in which the variables involved have only non-negative integral powers is called polynomial. Okay, so what is polynomial an algebraic expression in which the variables involved have only non-negative integral powers is called polynomial. Okay. So observe the definition carefully. An algebraic expression in which the variables involved have non-negative integral powers is called a polynomial. Okay. So all of you listen carefully and look at the board. So what is given definition about polynomial? Okay, polynomial. An algebraic expression contain the variables and constant numbers with non-negative integral powers is called polynomial. Okay, so non-negative integral powers means the power should be only positive. Okay, not negative. For example, see, suppose x square plus 3x power 4 minus 5x plus 6 is there. Okay. So if we observe the powers here, all are positive integers. X power 2 positive, x power 4 positive, here x power 1 positive. So like this, if all the powers are positive in the given algebraic expression, so that is called polynomial. Okay. So this is a polynomial, right? Suppose let us see one more example. Y cube minus 3y power 4 plus 6y square minus 8y plus 10. See here also, if we observe the all powers, see all are positive integers. Okay. So like this, if all the powers are positive integers in the given algebraic expression, so it is called polynomial. Okay. Now, suppose see one example here. If we observe one example, x power 4 minus 3x power minus 2 plus 6x plus 8 is there. See, in this algebraic expression, here one power negative is there. Okay. So if the power is negative, it is not a polynomial. Okay. And also, suppose x power 5 plus 3x power 1 by 2 plus 6x plus 9 is there. Here see, if we observe this power, this 1 by 2, it is not an integer. So according to definition of polynomials, all the powers should be positive integers. But here 1 by 2 is not integer. So this is also not polynomial. Okay. And if we observe one more example, x cube plus 2 by x power 4 minus 6x power 5 plus 8 is there. Okay. So is it polynomial? If we observe all the powers, here x power 3 positive, x power 4 positive is there, x power 5 also positive is there. Okay. So all the powers are positive. All the powers are positive integers. But generally if we see, we will think that it is a polynomial, but it is not a polynomial. Why it is not a polynomial means, see, x cube plus 2 by x power 4 is there, no? So when this x power 4 bring up, it becomes x power minus 4. X power plus 4 is there, no? When we bring up, it becomes x power minus 4, right? Minus 6x power 5 plus 8. See, when we bring this x power plus 4 up, it becomes x power minus 4. So here negative integer is there. So this is also not polynomial. It means polynomial is nothing but all the powers should be positive integers. If all the powers are positive integers, then only it is a polynomial. Otherwise, it is not a polynomial. So that's why here saying that an algebraic expression in which variables involved have only non-negative integral powers is called a polynomial. Okay. So here see children, some examples are given which are polynomials and which are not. Okay. See, if we observe this 2x, 1 by 3x minus 4, x square minus 2x minus 1, all the powers are positive is there. So these are all polynomials. Okay. And if we observe here x power 1 by 2 is not integer. So it is not a polynomial. And here 3x square plus 4x power minus 1 plus 5 is there. It is also not polynomial. Why? Because here the power negative is there. Right. So like this, if the powers are fractions are negative, it is not a polynomial. Right. So next, degree of a polynomial. This is very important, children. What is degree of a polynomial? See, degree of a polynomial is nothing but if P of x is a polynomial in x, the highest power of x in P of x is called degree of the polynomial. Okay. So, what is saying here degree of the polynomial? If P of x is a polynomial in x, the highest power of x in P of x is called degree of the polynomial. Okay. So let us see degree of the polynomial. So this is also very important, children, this concept. So all of you listen carefully. Degree of the polynomial. Degree of a polynomial. So degree of a polynomial is nothing but, see, take a polynomial. Okay. Suppose, for example, x power 4 plus 3x square minus 5x cube plus 6x plus 10 is there. So observe this polynomial. So in this given powers, what is highest power here? Here x power 4 is there, x power 2 is there, x power 3 is there, here x power nothing is there, means it is equal to 1. And this is the constant number. The power of any constant number is always 0. See, if we observe the powers, here what is highest power? 4 is highest power. So the degree of this polynomial is 4. It means in the given polynomial, the highest power is called degree of the polynomial. Okay, in the given polynomial, the highest power is called degree of the polynomial. Here highest power 4 is there, so the degree of this polynomial is 4. Let us see one more example. X square minus 5x power 4 plus 6x power 5 plus 8x minus 5 is given. Okay. See, if we observe the powers here x power 2 is there, x power 4 is there, x power 5 is there. Here x power nothing is there, means it is 1. And 5 is the constant number, this power is 0. So if we observe these powers, here 5 is highest power. 5 is the highest power. So the degree of this polynomial is 5. So like this, children, degree of the polynomial means the given polynomial, the highest power is called degree of the polynomial. Okay. So the next. Next one is value of a polynomial. What is value of polynomial? See, if P of x is a polynomial in x and if k is a real number, then the value obtained by replacing x by k in P of x is called value of P of x at x is equal to k, and it is denoted by P of k. See children, here P of x is a polynomial and k is a real number. So when we substitute that real number k in the given polynomial P of x, we get some result now. So that result only is called the value of the polynomial. So let us see one example here. Value of the polynomial. See here, value of a polynomial. So value of a polynomial, it means generally the polynomials are denoted by P of x. Polynomials are denoted by P of x. Okay. Suppose say for example, P of x is equal to a polynomial is there. Suppose x squared plus 5x plus 2. Okay. X squared plus 5x plus 2 is P of x. The polynomials are denoted by P of x. So P of x is equal to x squared plus 5x plus 2 is there. Okay. Suppose I am taking a real number when x is equal to 2. If x is equal to 2, a real number 2 I am taking in the place of x. So when we take the real number, so when we substitute this real number in the place of x, so what we get here when we substitute this real number 2 in the place of x, P of x becomes P of 2. Why? Because x value we have taken 2. Okay, in the place of x now we are writing 2. So here x square means 2 square plus 5x. 5x means 5 into x value 2 we have taken plus 2. So here 2 square value 2 2s are 4 plus 5 into 2 5 2s are 10 plus 2. How much total? 4 plus 10 14, 14 plus 2 16. So at last we have got 16, no? So this 16 is called the value of the given polynomial. Okay. So value of the polynomial is nothing but when we substitute a real number in the given polynomial, at last what result we are getting, so that result only is called the value of the given polynomial. So here when we substitute x value 2 in the given polynomial, at last we have got 16. So this 16 is called the value of the polynomial. Okay children? So this is about value of the polynomial. Now the next one is types of polynomials. Okay. The next one is types of polynomials. There are two types of polynomials. First one is linear polynomial. Okay, linear polynomial. So linear polynomial is nothing but a polynomial of degree is called linear polynomial. Okay. So in the given polynomial, if the degree is 1, it is called a linear polynomial. Example here, 2x plus 3, 5a minus 10. So what is the highest power here? X power 1, and here the 3 is the constant number, this power of 3 is 0. So degree is 1 here. In these two examples, degree 1 is there. So like this, if the degree is 1 of a polynomial, then it is called a linear polynomial. We are going to discuss now types of polynomials. So first one is linear polynomial. What is linear polynomial? If the degree is 1 of a polynomial, then it is called a linear polynomial. Okay. Next. Second one is quadratic polynomial. Okay, quadratic polynomial. So quadratic polynomial means if the degree is 2 of a polynomial, it is called quadratic polynomial. Okay, and next one is cubic polynomial. If the degree is 3, then it is called a cubic polynomial. So there are total 3 types of polynomials are there. First one is linear polynomial. Second one is quadratic polynomial, and third one is cubic polynomial. Okay, so linear polynomial means degree should be 1. If the degree of the polynomial is 1, it is called linear polynomial. So second one is quadratic polynomial. If the degree is 2 of a polynomial, then it is called quadratic polynomial. And the third one is cubic polynomial. If the degree is 3, it is called cubic polynomial. So these are the 3 types of polynomials. Okay. And the next topic is zero of a polynomial. Zero of a polynomial. So what is zero of the polynomial? See, a real number k is said to be a zero of a polynomial p of x if p of k is equal to 0. See here, p of x is a polynomial. So when we substitute a real number in the given polynomial p of x, at last, if we get 0, then that real number is called 0 of the polynomial. So let us see one example here. Now we are discussing about 0 of the polynomial. Okay. Zero of the polynomial. So 0 of the polynomial is nothing but, see children, a polynomial given. Suppose polynomials are generally denoted by p of x. Okay. So p of x is equal to a polynomial is given x square minus 16 is there. X square minus 16. So in this polynomial, suppose I am substituting x is equal to 4. Okay, x is equal to 4. So when we substitute x is equal to 4 in the given polynomial, now p of x becomes, what will it become? X value we have taken 4, no? So p of x becomes p of 4. So x square means it is 4 square, x value we have taken 4, minus 16. So how much we get here? 4 square value is 16, minus 16. 16 minus 16, how much? 0. It means when we substitute a real number in the given polynomial, at last, if we get 0, then that real number is called 0 of the polynomial. So here the real number we substituted 4. So here we have got 0. So now here this 4 is called 0 of the polynomial. Okay. So this is about 0 of the polynomial, children. And now we have discussed about what is polynomial, what is degree of, and what is the value of the polynomial and 0 of the polynomial. Okay. So now all of you open exercise 3.1. All of you open exercise 3.1. Now you got clear idea about polynomials, types of polynomials, value of the polynomials, and 0 of the polynomial. Okay. So all of you open exercise 3.1. See children, here exercise 3.1 is asking, in p of x, 5x power 7 minus 6x power 5 plus 7x minus 6. Asking here, coefficient of x power 5 is asking, and asking degree of p of x is asking. And here next asking constant term. Okay. So let us see. Okay, see children. In first question, it is given that p of x is equal to 5x power 7 minus 6x power 5 plus 7x minus 6 given. Asking first question, coefficient of x to 5. Coefficient of x power 5. So coefficient of x power 5 means we have to see x power 5 side number. Every time remember that coefficient means that which coefficient is asked, that side number we have to see. So here asked x power 5 coefficient here. So x power 5 side number we have to see. X power 5 side number how much is there? Minus 6 is there. So coefficient of x power 5 is minus 6. Suppose if they ask coefficient of x power 7, x power 7 side what number is there? 5 is there. So coefficient of x power 7 is 5. Right? Suppose if they ask what is coefficient of x, so x side number here 7 is there. So the coefficient of x is 7. Okay? So coefficient means side number. Side number we have to see. So here x power 5 coefficient is asked. X power 5 side number minus 6 is given. So minus 6 is the coefficient of x. And degree of p of x is asked. Degree of p of x. Already just now we have discussed what is degree. Okay. So degree means the highest power. So the highest power is called degree of the polynomial. So here in this, what is highest power? Clearly we know that 7 is the highest power. So the degree of this polynomial is 7. Okay. The degree of this polynomial is 7. Right. And the third question is asked here, what is constant term? Constant term is nothing but, here see, a number without variable is called constant number. Okay, a number without variable is called constant term. See here, in this term variable is there. In this term also variable. Variable is nothing but any alphabet. Okay, variable is nothing but any alphabet, x, y, z, p, q, r, a, b, c, like that. Okay. So here in this given polynomial, x variable is there. So in this term variable is there, x. In this term also variable x is there. In this term also variable x is there. But here there is no variable. Okay. So if there is no variable, that is called constant number. So how much is their constant number? Minus 6 is there. So minus 6 is the constant number. Okay. Right. Now see here, second bit. Second bit is asking, state which of the following statements are true and which are false. Give reasons for your choice. Here asking true or false. Okay. So observe the first question. The degree of the polynomial root 2x square minus 3x plus 1 is root 2. Is it true or false? Here the degree is given root 2. But here if we observe the degree, highest power is called degree now. So here highest power 2 is there. X power 2, this x power 1, and this 1 constant number, the power of any constant number is always 0. So what is highest power here? 2. But here the, so degree is 2 here. But degree how much given here? Root 2. So it is false. Okay, write the answer false. Reason, here reason also said no. So what is the reason? The reason is the degree of the given polynomial is 2. Okay, the degree of the given polynomial is 2, not root 2, right? Now see second one. The coefficient of x square in the polynomial p of x is equal to 3x cube minus 4x square plus 5x plus 7 is 2. Coefficient of x square. Just now I explained what is coefficient of x square. Coefficient of x square means x square side number we have to see. Here x square side number how much is there? Minus 4 is there. So coefficient of x square is minus 4 here. But here how much is given? 2 is given. So it is false. Okay, it is false. Because the degree of the given polynomial is, the coefficient of x square in the given polynomial is minus 4, not 2. Okay, and see the third statement, the degree of a constant term is 0. It is true, students. Why? Because just now we have discussed the degree of any constant term or any constant number is always 0. Okay, so the degree of any constant number or any constant term is always 0. So this statement is true. For true statement, it is not necessary to write the reason. Only you write the reason for false statement. So here the first reason is the degree of the polynomial is 2. Okay, and here this is false because the coefficient of x square in the given polynomial is minus 4. Okay, and see the fourth one. Fourth question is given 1 by x square minus 5x plus 6 is a quadratic polynomial given. 1 by x square minus 5x plus 6 is a quadratic polynomial. Okay. So just now we have discussed what is quadratic polynomial. What is quadratic polynomial? If the degree is 2 of a polynomial, it is called a quadratic polynomial. Okay. Okay, here degree 2 is there, but fraction is there now. So if we bring up, it becomes minus. So it is false. Okay, children, it is false. And the last question in this, the degree of a polynomial is 1 more than the number of terms in it. This is also false. Why? Because what is saying here, the degree of a polynomial is 1 more than the number of terms in it. This statement completely false. Why? Because the degree of the polynomial is not dependent on the number of terms. Terms how much also no problem, but the degree is main here. Okay, so it is not related. There is no relation between degree of the polynomial and number of terms. Okay, so this statement also false, right? Now see the third question. Third question, it is given that if P of t is equal to t cube minus 1, find the values of P of 1, P of minus 1, P of 0, P of 2 and P of minus 2. So this many values we have to find out. So what is given here? Here P of t is equal t cube minus 1 is given. So asking P of 1, P of minus 1, P of 0, P of 2 and P of minus 2. Okay, children. So let us see how to solve this problem. Okay, see here exercise 3.1. exercise 3.1. So third question. If P of t is equal to t cube minus 1 is given. Asking find P of 1, P of minus 1, P of 0, P of 2 and P of minus 2 values are asking. Okay. So let us see the first solution given. So what is given here? P of t is equal to given t cube minus 1. P of t is equal to t cube minus 1 is given. So asking P of 1 first. So first of all, you find P of 1, first one. P of 1. So P of 1 means here in the place of t, 1 came no. In the place of t, 1 came. So here also in the place of t, we have to substitute 1. So here t cube means t value 1 now. T cube means 1 cube minus 1. So what is the value of 1 cube? 1 cube value 1. 1 how many times multiplying also we get 1 only. Minus 1. So how much 1 minus 1? 0. It means P of 1 value is equal to 0. Right? Next. Second one asking P of minus 1. P of minus 1. P of minus 1 is nothing but in the place of t we have to substitute minus 1. Okay. So when we substitute minus 1 in the place of t, here t cube is there. It means minus 1 cube. Okay. Minus 1 cube and minus 1. T cube means minus 1 cube, minus 1, minus 1. So what is the value of minus 1 whole cube? Minus 1 whole cube value is equal to minus 1 only. See, minus 1 whole cube means minus 1 is multiplied 3 times. Minus 1 into minus 1 into minus 1. So when we multiply the symbols, minus into minus plus we get, again plus into minus, minus. Overall we get minus symbol. And 1 how many times multiplying also? Minus 1 whole cube value is equal to how much it is? Minus 1. And the remaining minus 1 as it is. Minus 1 and minus 1 how much it is? Minus 2. So P of minus 1 value is equal to minus 2. Okay. And see third one. Third one is asking P of 0. Okay. P of 0. So what is P of 0 here? It means now in the place of t 0 came now. So we also substitute 0 in the place of t. T cube means 0 cube minus 1. So what is the value of 0 cube? 0 how many times multiplying also we get 0 only. Right? So 0 cube value 0 minus 1. 0 minus 1 how much? Minus 1. It means P of 0 value is equal to minus 1. Okay. In the same way, children, do our homework, right?
Okay, thank you all.